In this project, we are assigned to perform an ordinary kriging using the data we collected as a part of our class. So the data is named as Trimble final data. So first of all, I imported the necessary libraries that are used to do this operation, and we are also given an image along with it. The image had a name, image underscore png. You can see it here. First of all, I converted that image into a raster file, and with the help of few commands, I uploaded it, and the image looks like this. After then, I set a working directory to work for my files. My working file is Trimble final data. I print out to look what it's look like. After then, I assigned a geometry with an APSC of 26915, which is UTM-15 NAD83. This command helps to plot all the data. You can see the diagram here. After then, I retrieve XYZ value from the geodata frame and store it in a separate list. So this code helps to determine the grid value for X and Y. After then, I use this coding to select the best variogram. Which variogram will fit my model, and plot it in the graph. So you can see that the error profile for spherical is very less compared to others. So our desired variogram is spherical one. And in this step, I perform the ordinary kriging by following some of the commands. I got the value of partial sill, full sill, range, and nugget as 0.049, 0.12, 4.95, and 0.07. After then, it is already sure that we have to use a spherical variogram. So with the help of the coding, by using some formulas, I got my variogram as this. You can see the figure that this is the spherical model and this is the empirical model. So finally, I create a contour plot of predicted surface elevation with the help of kriging. So you can see that these are the data that we collected, and it has a color map indicating the elevation values too. So you can see the elevation, and according to which it has a definite color. So after then, I use this code to generate a contour plot showing the prediction standard error for surface elevation. So the standard of error of estimated surface is clearly visible on this color bar. The more it is yellow, the more it has a standard error. So finally, we have to show that in which area of the plot or of the field we have to get our next value. So with the help of this command, where the model accuracy is the best, I use this command to predict the best in the area of model accuracy. I find out that this point is best for selecting the newer point because it has the least minimum error. Thank you. Hello, Professor. So today I am doing a presentation on our final project, question number 2, which is watershed delineation. And according to this question, we are assigned to select a county that is based on the first letter of our last surname. So I'm in city. So the city that I had to select is Lumberton, Texas. With the help of Texas city boundaries, I extracted the Lumberton, Texas boundary. I made a polygon out of it. I used it in an Earth Explorer, and I found out that only one footprint is required to cover the whole city. After then, I downloaded the BIL files. You can see the 4 BIL files here. So for further operation, I used Jupyter Notebook, Python. So first of all, I uploaded the necessary libraries, which is this, you can see, and I set up the working directory. I load the build files. After that, I used the Rasterio open to open my build file, and with the help of Mosaic outtransform merge dataset, I merged the datasets, and this code here, it is used to create a copy of the metadata from the first dataset in the dataset list. I use this command. After then, I use this code which opens a new GOT file, and I named it as mosaic output.tif. So this is the output. After then, I used many commands. I use Rasterio that reads the data from the first band and then retrieves it on a raster file. With a code of this profile, it gives a dimension, projection, and data type. And after then, I plot the figure and obtain the figure as this. So on further going, with the help of this data frame, I used a geo package which is called Lumberton City, and I clipped that previous file into our county map, and I got the required image like this. After then, on further going, I figure out what's the lowest elevation of my obtained output and in which coordinates it lies. So I got the coordinate as -94.2 and 30.21, and the lowest elevation is 5 meters. So in this code, I used it because it processes a DM by filling small pits, larger depression, and resolving flat areas, so that it will improve the hydrological modeling. So coming back to this code, I used directional mapping. It is for the east, east, west, north for all the 8 directions. So now in this code, it is used to generate a plot of flow accumulation. So I created a title, label, and you can see that the flow accumulation as latitude and longitude like this. So these were the lowest elevation point I obtained from the previous output. So I used it as a pour point for the X and Y, and I clipped it as the catch. So coming to this one, this code helps to plot the delineated catchment area on the DEM. So it uses a gray map, and you can see the label as latitude and longitude. You can see the catchment area. So this code extracts the river network with a high flow accumulation based on the different directions. So coming to this code, it plots the city boundary and river network. You can see here that I labeled the Lumberton city and different coordinates at its point. So this is the obtained file. So in this code, we calculated how far each cell is from the outlet best. So it visualizes the distance from each cell to the outlet using a color map. So you can see the distance that ranges from 0 to 20. So we have a latitude for this, and we have a different color variation for this, so we can obtain the distance as per it. So here, this is how I did my second assignment. Okay, thank you. Hello, Professor. So today I am doing a presentation on our assigned final project. I'm beginning with the surface reflectance derived spectral indices. So in this project, we are given to choose that county which is based on the last alphabet of our first surname. So according to which my county lies at Liberty and Hardin. I downloaded the county Texas boundaries, extracted Liberty and Hardin, and made a polygon out of it, defined it, and I used Earth Explorer to get my desired output data. So we are asked to select 3 winter scenes and 3 summer scenes. So I used the data range. I used the cloud cover up to 4% and extracted data as summer and winter, in which summer has 3 scenes. Every folder has 4 footprints because 4 footprints are needed to cover my whole county. After then, I used Python for the further processing. First of all, I import the necessary libraries, and in this segment, I asked Python to go through all of my subfolders and folders so that it will read all the TIF files that I have downloaded. So after then, I started mosaicing bands B1 to B7. For scene 1, there are 4 footprints, each of which have one band. So I mosaic each band B1, 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 B1. Similarly, I merge B7 like that way. And I obtain this output as summer 1, summer 2 like this. After then, I moved on calculating each scene and band mean, standard deviation, pixel similarity, and average difference. By the help of this command, I got the value of summer scene, winter scene 1 mean for each band, similarly for other scenes also. So coming to this command, I use this command to display this mean and standard deviation in the form of plot. So you can see that in scene 1, the winter mean and standard deviation, winter mean, it's supposedly to be high. Similarly, in scene 2, it is the same, but when coming back to scene 3, it seems that the stats of summer is more higher than the winter. So finally, I plotted all this band of summer and winter scene 1, scene 2, and scene 3 like this. Okay, thank you.